Hi, everyone. I'm Sandy Chaika from Riverside Brookfield High School just outside Chicago, Illinois, and I'm here to talk to you about using programs with data. So in this video, we're going to explore how to process data and use program to create common algorithms for analyzing the data. So what are we going to learn? Well, we want to be able to explain how programs can be used to gain insight and knowledge from data. In order to do that, we need to know that programs are used in an iterative and interactive way when processing information to gain that insight and knowledge. Programmers can use the programs to filter and clean data to help gain that insight. Sometimes we will combine data sources, cluster data, and even classify data for processing these programs to gain the insight and knowledge from the data. Insight and knowledge can be obtained from translating and transforming digitally represented data, and patterns can emerge when data are transformed using programs. So that's a lot to say. Let's look at an actual example. So I have a data set here which has AP test scores for 15 students. And they are actually three different sources. One was exam one was exam two, and one was for practice exam three. So we can use programs to actually look at the data, and these can be stored in types of lists to be processed. After filtering and cleaning the data, we can look at the programs and use them to see whatever kind of insight and knowledge we can gain. Again, this data has three sources of test scores as three different practice exams. So let's use a program to sort and look for trends. So we have the data right here in a table. Here's a new table that I created using a program. This data has for each exam the students from lowest to highest, their IDs. So when I look at this, I can see a few different trends. The same student has scored the lowest on all three exams. At the opposite end, the same student has scored the highest on all three. But we see in between that there's a little bit of movement. It's not always the same student scoring the lowest or scoring the highest. They don't stay in the exact same order. So that gives me an idea of where we're doing, who might be struggling the most, who might be really strong, and what students I can help in what ways. I also might want to highlight some trends. So in this scenario, I went ahead and put the students in order again for the third practice exam. But what I did do is I looked at from practice exam one to practice exam two. And if in exam two they scored higher than exam one, I highlighted those test scores. Then I took practice exam three. And if they scored higher in three than in two, I highlighted those test scores. So this really gives me a nice picture very quickly, and I can gain some insight very easily. I can see that a fair number of people improved from one to two, but almost everyone improved from two to three. And actually, the one person I can look at very quickly now didn't actually go down, they just stayed the same. So, as a teacher, that makes me pretty happy that they're going in the right direction. So, this is giving me some information. I can look at it in more detail. I could actually look at what's the maximum score between the three scores and make sure that that actually is an exam three. So there's a lot of different things I can look at here, and highlighting actually can help me see that very quickly. I also might want to summarize the data. So for instance, I might want to summarize the data by average. So I put the average of all of exam one in this cell, which is a 43. For exam two, the average is a 47.13. And for exam three, the average is 54.53. I can quickly see that all of the averages definitely went up from each exam. I could have transformed the data if for some reason I wanted to curve the scores, curve the final grades I gave my students. I could add a certain number to every single score and transform that data, and then my average would be updated automatically. So there's different ways the users can interact with this data. We could filter it, we might sort it, we might combine some of the different pieces, we might transform the data, we might put them into clusters or even classify them. The key is that the user gets to interact with it, and each interaction might lead to a new iteration, meaning some new questions that we can answer, some new processing that might give us more information and insight into what we are looking at. This makes it really useful and actually even kind of fun if you really are looking at data you're interested in. So, what should you take away? Well, I want you to be able to explain how programs can be used to gain insight and knowledge from data. In order to do this, we need to know that programs can be used in iterative and interactive way when processing information. We can use the programs to filter and clean digital data. We can combine data sources, cluster data, classify data. And all of this leads to insight and knowledge from the data that can be obtained from translating and transforming our digitally represented information. Hopefully, you'll see some patterns that emerge when data are transformed using our programs. Thank you for watching this data. I'm hoping you'll come back and watch some more information about data in some of our other videos. In the meantime, go out and have some fun with CS.